Hello friends, welcome back to another video in the series of videos for learning basics of coding. In the last video we talked about variables and data types. Today I wanted to delve into another concept related to variables and data types, which is how the data is stored for the variables. Uh, so like we know, a computer program is basically compiled into zeros and ones, which is the machine language, basically a language that the computer can understand. Similarly, variables are stored in memory in the form of zeros and ones. The very basic building block or the very basic unit of storage in a computer memory is a bit, and a bit can store a 0 or a 1. We will typically have multiple bits or a block or array of bits to store data. So for example, here I have in this example 4 bits storing data, and the highest value that these bits can store is all the bits having one set on them. So basically 1 1 1 1, and this turns out to be so this is the binary value, and it turns out to be decimal value 15. And we can see a pattern here. We will see that this number is 2 raised to the number of bits minus 1, which is 15. Now typically most of the data types storing numbers might also store negative values. In this case, the leftmost bit is not used to store the number. It is used to store the sign or kind of an indication that it's a negative number. So for example, we will have a positive value 1 1 1, which would be 2 raised to 3 minus 1, which is 7, and the leftmost bit will be 0. Now the way negative values can be stored can vary. There are multiple methods. The simplest is ones complement, which I'm going to talk about. So basically in one complement, what would happen is all the bits will be shifted or will be flipped, and the leftmost bit will become 1. So for example, if it's 0 1 1 1 represents 7, minus 1 will be represented by 1 0 0 0. So all the bits have been flipped. The leftmost 0 became 1, and the rest of the ones became 0. So when reading this value, the computer will know that the first bit or the leftmost bit is 1, so it is a negative number, so it's just going to flip the 0 0 0, get the number 7, and since it knew that this was a negative number, it's going to return minus 7. So let's go to a larger number, and we'll generally see that most of the data types will be in terms of uh, bits of size 8, which is a byte. So 8 bits come together to make 1 byte, and for a data type which might not store negative numbers, all the 8 bits would be used, and the maximum value would be 2 raised to 8 minus 1, which is equal to 255. For a data type which might store which probably might store negative numbers as well, it would be 2 raised to 7 minus 1, which would be 127, and the leftmost bit would be used to indicate the sign. There are a few other methods which are used to store negative numbers. 2's complement is another one. I will not be getting into details of other methods, as well as neither will I be getting into bitwise operations. these are topics that will require their own videos. But this should kind of give a good idea how the numbers are stored in the bits or in the memory. Now, what about characters or strings? So, character is represented internally using its ASCII value, which itself is a number, and then that number can be stored again in the same way as we will store any other number. Let me quickly shift to the another table which kind of shows the typical size each of this data type will have. Unsigned basically means it stores only positive values. So the leftmost bit is also used to store the data, and signed would mean that it can store negative values, and the leftmost bit would be used to store the sign, and the rest of the bits would be used to store the data depending on the method, one's complement, two's complement, or any other method. So let's get into some coding, and here I already have some code written, and I wanted to demonstrate the size of operator that we can use in C++ to get the size of a variable. So I have declared different data types, as well as I have declared a couple of characters, but I'm storing them in a integer variable because I wanted to demonstrate the ASCII values of these. So let's go ahead and build the program. I previously built it, so it kind of says there is no change has been made to the code. So yeah, I think we're just good to go ahead and run this program. And we should be seeing the output shortly, which should be the size of the various variables. And let's have a look. So I is an integer, it's taking 4 bytes. All these numbers are in bytes. Float is taking, f is float, which is taking 4 bytes. Long, now I'm declaring long int here, and this is basically a long, and it is taking 8 bytes. It's double of integer because it can store a longer or a larger number, and double similarly is double of float, which is 4 bytes. Double is 8 bytes. So double can store a larger decimal, a higher precision. Boolean, b is a boolean variable here, and it takes 1 byte. Char takes 1 byte, and here we see the ASCII values of capital A as well as lowercase a. So uppercase or capital A has an ASCII value of 65, whereas lowercase a has an ASCII value of 97. Now remember that since we are storing this in integer variables, even though it's a character, these are going to take 4 bytes because an int takes space of 4 bytes. So this should pretty much give a good idea of the various sizes of any data type, and if you don't know, you can use the size of operator. Now another point I want to talk about is of composite data types. Composite data types, the size would be the sum of the data types that make up a composite data type. For example, if I declare a struct and I had an integer and a char a variable in that, it would take 5 bytes of size, because integer takes 4 bytes and a character takes 1 byte. So and the size of operator will also work on composite data type. It's a pretty useful operator that we will see being used frequently in subsequent programs. Thank you.